We will be examining the proton NMR of propyl salicylate. Okay, as you can see from this spectra, there are 8 different signals to be interpreted. These 8 different signals represent that there are 8 different protons in this structure. Whether or not a proton is the same or different depends on the surrounding atoms of the proton. In our structure, each proton is surrounded by different atoms on both sides, so the molecule is not symmetric in any way. Proton A, here, also seen here in the spectra, represents an alcohol, which is attached to the benzene ring. The signal is at 10.6 ppm, which is further down the spectra than a normal alcohol, which is usually found between 3.4 and 4. This is because the benzene ring is causing the signal to shift downstream. Protons B, C, D, and E, these here, which are also these protons here in the structure, are in between 6.5 and 8 and are representing the different protons on the aromatic ring itself. Proton F, which is here in the structure and here on the spectra, represents the CH2, which is closest to the ester functional group here, which is causing it to shift further downstream than protons G and J, which are here and here. Proton G is located here at 1.785, and it is further down than J because it's closer to the ester but not as close as F. And then proton J, which is here in the structure, is at 1.0, and that is representing the CH3. The next things to look at are the integration numbers, which I have put on the spectra for us, and that is represented by these numbers here next to each of the letters. The integration number just represents the number of hydrogens that are attached to that atom. Normally these are given to you. If they're not, they can be obtained if you know the structure. So if we look at A here, we can see that there is only one proton attached to that, so that gives you the integration number of 1. It is the same for B, C, D, and E, which also have only one proton attached, given the integration number of 1. Protons F and C have 2 hydrogens attached to those carbons, giving you the integration number of 2, and J has 3 hydrogens attached, giving you the integration number of 3. These numbers are normally read as a ratio, so the integration going from left to right is going to be 1 to 1 to 1 to 1 to 1 to 2 to 2 to 3. The last thing we want to examine is the splitting of each of the signals. This is hard to see in our spectra, but can be determined by the formula of N plus 1, where N is equal to the number of hydrogens on the surrounding atoms. So if we start with signal A, we will look at the surrounding atoms and see that there is only one hydrogen that surrounds it, since this on this side is a carbon. And if we plug that in, N plus 1, you would see that A would have a splitting of 2. If we move on to B, which is down here, we would do the same thing. And notice that on one side there's a hydrogen, on the other there's a carbon, so it too would have a splitting of 2 once plugged into the formula. If you then look at C, you would notice that there's a hydrogen on both sides, and so plugging that into the formula, you would have 2 plus 1, which would give you a splitting of 3. If you then look at D, which is here, you would see that there's a hydrogen on this side, but on this side it's attached to an oxygen, so it would have a splitting of 1 plus 1, which would give you a splitting of 2. E, which is over down here, also has 2 hydrogens on each side, giving you a 2 plus 1, which would give you a split of 3. And then if you look at F, which is here, you would see that there are no hydrogens on this side because it's an oxygen, and 2 on this side, so it would give you 2 plus 1, which is another splitting of 3. And then if you look at G, you can see that G has 2 hydrogens on the side and 3 hydrogens on the side, giving you 5, plus 1, which would give you a splitting of 6. And then if you look at J, you see that there are only 2, so 2 plus 1 would then give you a splitting of 3. That is all the information that you can obtain from a proton NMR and how and what it means.